So hopefully everyone can hear the video. This is the lesson in Chapter 1, and the Chapter 1 study guide, also known as the note-taking guide in geometry. And this is the lesson on section 1 through 2, Chapter 3, Section 3, Part 2. The first thing you might want to do is write this somewhere in your booklet. If you want to put it perhaps in the margin over here, I think that would be a good idea. So if you want a copy of this over here, go ahead and pause the video and do that at this time. This is a list of perfect square numbers. So 4, 9, 16, 25, 36, these are all numbers that are called perfect squares because they are the square of some other number. 3 squared is 9, 4 squared is 16, and 8 squared is 64, for example. So one of the things we can do with these types of special numbers is simplify other square roots. Now, something that I've seen a lot of students do when I ask them to find the square root of 150 is they go, oh, I know how to find the square root of 150. I take the square root of 150 and I hit enter on my calculator. Yahoo, I'm done. Well, in this section, if this is the best you can do, is simply find the square root on your calculator. You can get C-level credit, but you won't be able to get a B or an A on this quiz. So if you're asked to do this and you can't really do much with it other than plunk it into your calculator, if you can round this off to the nearest tenth, so that would be 12.2, then you get the C level. Now, I would think that people can do better than that. I think an average 10th grader should be able to go beyond just that. So what we're going to be doing today is showing you how to put it, rather than in decimal form, I'm going to show you how to put it in something called radical form. So what we're going to do is we're going to use something called prime factorization. Basically, factoring just means we're going to break down the square root of 150 into factors, which are things that multiply together to be 150. Now, the key is that one of these two square root factors has to come from this list. So, for example, 25. I know that if I tested it out on my calculator, tried a few 150 divided by 9, that doesn't work. 150 divided by 16, that doesn't work. 150 divided by 25, that works. 150 is divisible by 25. 25 goes into 156 times. So that could be our two factors. 25 times 6 is 150. So root 25 times root 6 would be the same as root 150. Now, as I said, one of these two numbers has to come from this list. So the reason for that is that that's how we simplify. Simplifying means we're changing a number from a more complex form to a more simple form. And this part right here, we can do that. Since the square root of 25 is more simply written as 5, that I can change to just 5. Unfortunately, the square root of 6 cannot be simplified. That part just has to stay the square root of 6. So that is something called radical form. We're going to simplify our square root and write it in radical form. And there you go. So there's a whole page of these. You could do the square root of 90, for example. The square root of 90, we're going to try to find one of these numbers on the left-hand column that goes into 90. Some of you may be thinking, hey, 9 goes into 90 10 times. Yep, me too. So I'll rewrite the square root of 90 as the square root of 9 and the square root of 10 multiplied together. And that will allow us to truly simplify at least part of this. The square root of 9 can be simplified, written more simply, as just 3. The square root of 10, no. The square root of 10 cannot be simplified any further. So we'll just write that, the square root of 10. So that is the radical form, simplified radical form of the square root of 90. 3 root 10. Square root of 60, 60. Does 4 go into 60? Yeah, I think it does. 4 goes into 60 15 times. Some of these other ones are obviously too big. 25 doesn't go into 60, 16 doesn't go into 60. So 4 seems to be the ticket. So since 4 times 15 is 60, then root 4 times root 15 equals root 60. So here's my special square root. It's a perfect square number. So when we take the square root of it, we actually get another whole number. So we can simplify the square root of 4 into just 2. Square root of 15 cannot be simplified. There are no other numbers here that go into 15 evenly that we could factor out. So there you go. So on this page there are several other examples for practice. Let's do a few more. Let's do number 5, the square root of 28. Well, 28 is 7 times 4, so we could break that down, because 4 is a square root, or a perfect square number, into the square root of 4 times the square root of 7, and then we'd be able to simplify that to just plain old 2. Square root of 7 cannot be simplified any further. Let's see. How about the square root of 54? Well, the square root of 54, the number 54, does 25 go into 54? No, 25 goes into 50, so that wouldn't work. Does 16 go into 54 evenly? Well, you take your calculator and you divide 54 by 16. No, it doesn't go in evenly. Well, I know that 9 times 6 is 54, so 9 would work. So I'm going to go ahead and use that one. So since 9 times 6 is 54, then the square root of 9 times the square root of 6 would have to be the square root of 54. The next step is to simplify our special square root that we chose from the list, the square root of 9, which is 3. Square root of 6 cannot be simplified, so we just leave it. Now your teacher may choose to go a little bit more in depth. As you can see, these two answers are a little bit more complicated. They may choose to go into those more in depth in class. But for right now, I'm going to move on to show you how we can apply this learning. Section 132 is actually, for the most part, on something called the distance formula. The distance formula basically says that if you take any 2 points, for example, point A right here, and point B right here on a graph, that you should be able to figure out the distance between them in graph units by subtracting the x values of the coordinate points. So you could take x sub 2 minus x sub 1, take that quantity and square it, and then take y sub 2 minus y sub 1, the two y values of these points, take that quantity and square it, add those two values together, and then take the square root of the whole thing. So we're going to do a couple of examples of how I can walk you through that process. So as you can see, point R has an x value of 3 and a y value of 2. I'm going to call that x1 and y1, x sub 1 and y sub 1, because that's the first x I see and the first y value that I see as I read. And then here's the second point. So point T has an x value of -4 and a y value of 3. This is the second x value I've come across and the second y value I've come across. So I label them x sub 2 for this value and y sub 2 for that value. So to find the distance between these two, all I want to do is use the formula. I'm going to actually write down the formula first so you can see how I'm interpreting it. So the distance from R to T is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, x sub 2 is -4, and we're subtracting x sub 1, which is 3. Close parentheses, squared. Y sub 2 is 3 minus y sub 1, which is 2. close parentheses, squared. Negative 4 minus 3 is the same as negative 4 plus negative 3. Either way, you're going to get negative 7. 3 take away 2 is 1. Now, how do you square something? Well, when you square something, you're just multiplying that number by itself. So negative 7 squared is negative 7 times negative 7. Or, in this case, 1 squared is 1 times 1. So negative 7 times negative 7 is positive 49, and 1 times 1 is 1. So if we take the square root of everything, we can add this together first to get the square root of 50. Now at this point, if you cannot simplify any further using this list of numbers, you can simply use your calculator, take the square root of 50, square root of 50, and round it off to the nearest tenth. This would be 7.1 rounded off to the nearest tenth. Or, in order to get this a B level credit for this question, you can use these numbers to simplify. So for example, the square root of 50 would be not divisible by 4 or 9 or 16, but 50 can be broken down into 25 times something. More specifically, 25 times 2. So the square root of 25 times the square root of 2 is the same as square root of 50. This is our special square root value. It's one of the few that can be simplified to be a regular number. So I'm going to simplify the square root of 25 to be just regular 5. Unfortunately, the square root of 2, no, can't do any more with that. So we just bring that down and write our answer, 5 root 2. Our last example for section or part 132, chapter 1, section 3, part 2, is just one last example using the distance formula. So here's an x and a y value that they give me. They're the first ones, so I'm going to write little 1s here. Here's the second x and y they give me, so I'm going to use subscript 2's there. And so to find the distance between these 2 points, find the length of line segment GH, I'm going to write down the distance formula. So x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Alright, x sub 2 is the value negative 3, and we're going to subtract x sub 1, which is 5. Close parentheses, squared. Y sub 2 is 6 minus y sub 1, which is negative 1, close parentheses, squared. So what do we have? Well, negative 3 minus 5 is like adding a negative 3 and a negative 5, which gives you negative 8. These two negatives cancel each other out, because when you subtract a negative, you're actually adding a positive. So believe it or not, this is just 6 plus 1, which gives you 7, and that's squared. So remember what I said about squaring, that when you square something, that's just taking that number and multiplying it by itself. So negative 8 squared is just negative 8 times negative 8, and 7 squared is just 7 times 7. So negative 8 times negative 8 is positive 64, and 7 times 7 is 49. When you add those two values together, you get the square root of 113. Now, 113, does 4 go into 113? No. Does 9? No. Does 16? No. If I divided 113 by each one of these values here, 4, 9, 16, 25, 36, 49, and so on, none of these numbers would divide evenly into 113. That means it's a prime value, at least inside the radical it is, and we can't break it down into factors that could be simplified, at least in part. So we can just leave it like this. Now, most of the time on your tests and quizzes, you will not get numbers like this that you just leave. Pretty much all the tests and quizzes that I can think of, this year, you will be able to either simplify it like this, or they'll ask you to give a decimal approximation, like I showed you with my calculator with the square root of 50.